So we're going to talk about paradigms of machine learning today. So it's better explained through examples. Okay, so let's take a look what I mean by examples. All right, here it is. Uh, what is a tree? Okay, so if we see a tree like this, those super trees downtown, uh, we know what they are, right? But there are some problems, right? We can't really describe why this is a tree. Well, it's got branches, it's got a trunk, but it's not natural, right? So the whole idea is that when we are tasked with this problem, right, even as adults, when we're trying to define a tree and a toddler asks us, is that a tree or not? Yeah, but how can you describe it, right? So there's a pattern to it, but it's not easy to formally pin down, right? Many times for machines, we need to encode a program for it. So we'd like to encode it through an algorithm or mathematically. That would be the most appropriate way to say this, okay? But we don't have that here. So we can't do that. We can't formalize a pattern for it. But the good thing is for trees, there are lots of examples out there, right? You just go outside when there's no COVID-19 and you can walk around and you can see lots of trees. They differ, of course, in Singapore from other places in the world that are more temperate, okay? But we have data for it, okay? So really, there are three different criteria that describe when we want to apply machine learning. Okay. So let me give you another example. All right. One is from Netflix. So many of you probably use Netflix or another site. Maybe you watch Korean dramas on Viki or whatever. Doesn't matter. The whole point is like when we are watching videos, maybe after we watch a video, for example, on YouTube, we want to be recommended with another one because we're a little lazy, right? We don't want to search for information. We want to have it sent to us. Okay. So this idea comes from the idea of being able to recommend, right? So you can have a system that asks you, hey, did you like this video? Maybe it was terrible. You don't want to watch anything like that again. Okay. And Netflix, when it was still sending DVDs, so back in the day, right, a long time ago, they used to actually mail out DVDs. I used to subscribe to this. This is how ancient I am. Okay. And then you would get them in the mail and then you'd watch them for however long you'd like. There's no like a late fee or whatever, and then you'd send it back, okay? But they wanted to take some analytics even at that stage and to recommend which other things you should watch, okay? So the whole point about this is that you would have a big matrix. That matrix had users on as rows and items as columns, okay? And at the intersection of a row and a column would be a cell, and that cell would contain perhaps your rating for that particular video or DVD or whatever you'd like, okay? The idea was to try to figure out what other items you might want to watch given that, okay? And so Netflix was thinking, they talked to a couple industry experts in this area in information retrieval, which is another specialty that I used to do more of. And they said, we're going to make it a researcher's job. Okay, we're going to open it up to a competition and we'll hold a prize. Okay, we'll give you $1 million if you can improve our algorithm by 10%. Okay, so those of you taking competitive programming, maybe you're like, hey, that's no problem. I just need to make it sublinear and then it's all okay. Okay, the whole point was, they didn't care about the efficiency, they cared about the precision and accuracy. We'll talk more about those metrics later. Okay, and they had to figure out a way of improving the algorithm through the use of, tapping on academia. And we'll talk much more about this particular prize when we come to week 10, because it's leading into our lecture on decision trees and ensembles. But basically, people were able to improve it. Somebody won the prize. Well, actually, a team of people won a prize. This $1 million, it wasn't a lot after US taxes, never mind. And then, unfortunately, Netflix couldn't use the algorithm, okay, because they only thought about accuracy. They didn't think about runtime efficiency. So it wasn't something that they could actually use. Okay, anyways, it's time to do an assessment, okay? So what we're going to do is find the 0-1 assessment in coursemology. So we're gonna go do that. Here we are, there's that guy again. Let's get rid of him. Okay, I don't wanna go there. I'm gonna go here, okay? And I'm going to attempt the submission. This is the one for the pre-lecture, okay? So pre means pre-tutorial, okay? Post means after tutorial, okay? So we're just going to go ahead and attempt that, okay? And many of you have already done this, but if you haven't, that's perfectly fine. This is why we're doing it together today, to give you an idea of how the course actually works. So Coursemology is doing something of this sort, where we're trying to get you to do all of the work in the notebook, okay? So you have this notebook, you can type whatever you want in here. Is this the one that I own? No, this one is, okay. So you can write whatever you want to put in here. So I'm just gonna replace with my answer, okay? So that when I revise for this course and I print out my notebook. Now, notebooks are not so nice to print out, okay, but never mind, try your best. Then you can just type in whatever answer you want. Maybe it's called, I think, okay. So I'm assuming everyone can hear and see, all right? I'm sorry about the glitch, all right? So we'll go ahead. So when you type in an answer here, obviously it doesn't go anywhere. This is just for your own edification, right? So what we want to make sure to do is to have it actually graded by our TAs. And so what you have to do is, Control C, Control V, or Apple, or, curly, whatever, if you're on the Mac, okay? And then put it here and then submit it. And you can save it as a draft if you're not sure about it. And you can submit it after you're done, okay? And then it should give you some feedback. We're still working on the feedback, we hope to improve it so that you get more of an error correction if you didn't do it correctly, all right? So let's go on, okay? So we have another question here and you're like, okay, where does that come from? Well, we have to continue following the notebook, okay? So that's basically the whole workflow, is that you have a notebook, okay? You read the notebook through. There'll be sections that are repetitions from the lecture. Those will hopefully be highlighted as being repetitive, so you can skip it, okay? It might be helpful when you come to revise. If you just want to revise one channel, either the slides or the notebooks, then you can refer to the notebook or the slides, okay? But anyways, we'll continue and we'll come back to question 2, okay, this question later, all right? So you can see what we're doing. We can say that we have basically 2 vectors, okay? One is the user preference. We're going to call this a vector V, okay? And one that encodes some type of information about the movie's metadata, okay? Like which actors is it, what type of genre it is, when it came out, etc. Okay, and so you can think of these vectors as just having individual components. Those components will have a value that signifies something, okay? Like there might be some encoding that Charlie Sheen was in this movie, or Denzel Washington was in this movie, or whatever like that, or Dick Lee or whoever. All right, so we're going to encode these vectors for the movie's metadata, and another vector for the user's preferences, okay? So the user's preferences might contain some information that they like a certain genre, or that they're a certain age, or they like to watch movies on Friday nights, but not during weekdays, etc. Or they could actually be this user item matrix that I talked about earlier, which is, for a particular movie, for a particular person, what was their rating for that particular item, okay? So that's the idea there. Okay. Another one that we're going to return to many times during our lecture is this idea of credit approval. Okay. So that's easy to understand. You go to a bank, you want to loan some money, maybe your parents need some money because of COVID-19 or whatever. Then you can apply for a loan and hopefully the bank will grant it to you. But behind the scenes, when you put in a loan application, basically the bank has a decision problem. Should they loan you the money or not? Okay, and that's going to be dependent on what you fill out, assuming that you filled out the form truthfully. Okay, so they obviously want to do a good job of that, because if you approve a case where somebody doesn't repay you, basically the bank has lost the money, right? They're not going to get it back. Maybe they'll sue you if it was a lot, but basically they're making a loss. Okay. On the other hand, if they reject somebody who is going to be able to pay back the loan with the actual interest, and they reject it, well, then they have an opportunity cost. They're losing money that they could have made, right? Okay, so these are the same type of inputs. Basically, you have a vector. Each vector is now one credit application, right? So there's a name, an age, how much money you make, if any, maybe other pieces of information that they should or should not use, like your ethnicity, etc. Okay, and from that, they're going to determine whether to loan you the money or not. Now, really, this is a regression problem. We'll talk about that more later. Regression just means we need real value outputs, how much money I should lend you. But for now, let's think of it as just a very simple Boolean decision problem. Either yes, you got the money, or no, don't get the money. Okay, so that's the output that we want to get from this vector. Got all these pieces of information on the form. Then we run that, and then after that, the decision-making algorithm, which we're going to call a machine learning system, is going to spit out an answer, yes or no. Okay. So, which of the three criteria is absolutely essential for ML to work? Okay, so you might be wondering, what is he talking about? Oh, here they are. All right, a pattern exists. It's difficult to formalize and pin down mathematically, or we have data for it. Okay, so we'll go back to our question here and just think about it. Maybe it needs to have a pattern. Okay, so I'm going to submit that, and let's see. Oops, that didn't look right. Okay, so it says here, some data sets may have strong patterns or ones that are easily captured. We'll talk about that next week. But maybe we can try again. Okay, so let's try, we have data. Maybe that's the right one. Okay, so I'm gonna try that. Okay, so actually you could try this a couple times and see how it works. Okay, when you get the right answer, then finalize that submission and go on. Okay, so we're gonna continue. And then we have the next question, right? Okay, all right, so we haven't done the next question yet, but we're gonna continue through here. Okay, so basically we need data, right? If we don't have data, we're not in the right business. If we want to make decisions and we want to use AI, but we don't have data, there's another area called expert systems that addresses that. That's yet another course to NUS at the 4,000 level. You can take that too. Okay, that's trying to encode what's in our brains here, the gray matter between our ears, try to write that out into a set of rules that we can use to create decisions. Okay, that's very similar to what a lot of people do. Okay, but machine learning is not like that, right? It's an optimization problem where you have lots of data. You've got data and you try to figure out what is the right way of engineering decision just based on the data alone. Okay, so even if there's no strong pattern, as long as you have data, you can make a decision, although maybe it's not very good data. For example, you can imagine if you're trying to predict whether it's raining outside and the only thing you have is a feature that tells you whether the person coming in is wearing a red t-shirt or not, yes or no, then trying to predict whether it's raining outside just from that information alone is going to be terrible, right? But you could do it, right? Because you have data. Maybe you have 1 million observations of people with red t-shirts or without red t-shirts, and there's some small correlation or whatever, then you can try to learn from that. Okay, it'll be a spurious model that doesn't probably do very well. It might coincidentally do very well for certain days. For example, National Day, if everyone goes out in red t-shirts, probably it's not raining outside. Then you would have a system, you have machine learned it, but it probably doesn't conform to what we call test data, meaning other samples that are not observed in the training data. Okay, so we can say what happens when the essential criterion is missing. Okay, so this is a free text answer as you saw over here. Okay, so we can say, when we have essential criteria is missing, we can't learn anything because, we don't have any data. We don't have any evidence. Okay. Okay, so you've already noticed I like emojis, but it's a little harder to write that on a Windows keyboard, so I'm not going to bother. Okay, so for free text answers, you'll notice it will tell you nothing, right? You could have gone back and wrote a whole bunch of stuff. I have no idea. Also, frowny face, right? And if you submitted that, it'll just tell you the same thing, okay? Because we don't have any natural language processing in this system yet. Okay, so the TAs will be looking at your answers for your free text answers, and they'll be bringing it back to you through tutorial or through the weekly emails, okay, and critique it. Okay, so I'm gonna pretend that I don't know what I'm doing. Okay, and I'm done with that question. Okay, so I'm now on question 4, so we'll come back to that. That's another part here. Okay, all right. And so what I want to do is, I didn't realize that line is actually visible to you guys. Okay, let me take it off. Where is the annotation panel? I want to clear it again. Okay, good. All right. Okay. So we're basically going to say that when we have a credit card application, it's got some vector values, right? So these are all of our components, right? These are 32 male, 40K of income, $26,000 in debt after taking lots of NUS courses, then years in the job, years of current residence. So this is a vector. It's a row vector, of course. You know your vector calculus. So usually we have column vectors, so we've just transposed it here. Okay, and then what we just want to do with this is decide whether it's approve or reject. So this is our y value.